So let's continue again with another problem. Here, this is an engineering application, specifically for chemical engineering. So I think this is fair, no, because I'm mechanical, you're a computer. However, in this problem, um, we have a system of a 5 interconnected or coupled reactors, to which each reactors has its concentrations. And since we have 5 reactors here, so the following, we will create a governing equation, which is there are also 5. So starting here with given, um, we have to split up, no, the the reactors. So free body diagram. So we could clearly look at it. So yeah. So for C1 we have going out of Q15, going out with Q12, going in with Q31, then going in with Q01 and CO1, reactor 1. Reactor 2, C2, which is going out Q25, going out Q24, going out Q23, then going in Q12. Reactor 3, so we have going in Q23, going out Q34, going in QO3, then CO3, then going out Q31. Reactor 4, we have here C4, going in Q54, going out Q44, going in Q34, then going in Q24. Reactor 5, lastly, we have going out Q55, going out Q54, going in Q25, then going in Q15. Okay, from the law of conservation of mass, this is particularly an application from your physics. So what conservation of mass ni siya, ha? So what goes in is equals to what goes out. So for reactor 1, as you can see, the in here is actually we're talking about mass, no? And in particular theory in chemical engineering, the mass flow there is equivalent to the volume flow times the concentration. So the mass is equals to Q times C. So the mass of in, which is this part and this part, so Q01 times CO1 plus Q31. Ang kaning Q31 coming from the reactor 3, so we multiplied it with C3, which is equals to what goes out, Q12 out from the reactor 1, which is C1, and also with Q15, Q15C1. Now we have a values here, so we will plug in directly. So that is 5 times 10 plus Q31, which is 1. And so this is C3 plus Q12, which is 3, C1 plus Q15, which is 3, C1. Simplifying, this is equals to 50 plus C3 is equals to 6C1. And we will just arrange directly, no? So your reactor 1 will be equals to 6C1 minus C3 is equals to 50. So this will be your equation 1 for reactor 1. How about for reactor 2? Looking back to the free body diagram, we have here going in, which is Q12 from the reactor 1, C1. Then 3 outputs starting from Q23, C2 plus Q24, C2 plus babaw, which is Q25 plus Q25 C2. Now plugging in the values, so for 1, 2, that is 3 C2, 2, 4, that is 1, so that is plus C2 plus equals din eh. This is equals C2 2, 4, which is 1 also, so that is C2 plus 2, 5, which is 1, so that is C2. So that is equivalent to where is this? 3 C2 is equals to 3. No, this is C1. Sorry. So that should be 3 C1 is equals to C2 plus C2 plus C2, that is 3 C2 is equals to 3 C1. In other words, C2 is equals to C1. So reactor 3, so for reactor 3, looking back, so that is input of Q03 CO3 input plus Q23 from C2, no? Then going out Q34 C3 plus Q31 C3. Plugging in the values, Q03 is 8 times C of 20 plus Q23 of 1 C2 equals Q24 Q34 8 C3 plus Q31 of 1 C3. So that is 160 plus C2 equals to 9C3. So therefore, 9 C2, that is negative C2 plus 9C3 is equals to 160. For reactor 4, we have looking here, so that is going in Q24 from let's just drag this Q24, which from C2, and going in also Q34 from C3, going out Q44 C4 ay napadayo sa kain. So humsa na to. So that is Q34 na plus Q54 C5 equal to out Q44 C4. Q24 is 1, so that is C2 plus 348 C3 plus Q54 2 C5 is equals to 11 C4. In general, your equation is C2 minus 8 C3 plus 11 C4 minus 2 C5 is equals to 0. So equation 1, equation 2, equation 3, equation 4. So for reactor 5, we have C15 Q15 C1 plus Q25 C2 is equals to Q54 C5 plus Q55 C5. Q15 is 3 C1, Q25 is 1 C2, Q54 is 2 C5 plus Q55 of 2 C5. So that is around negative 3 C1 minus C2 plus 4 C5 is equals to 0. This is your equation 5. So notice that akong kipangsud tanang variables, then what remains on the right hand side of the equations are those do not have variables or constants. So since there are two equations with constants, so the rest is equals to 0. Now since we have the equations, let's use first the matrix inverse. So matrix inverse method, translating the 5 equations into a matrix, we have here first is for C1, C2, C3, C4, C5, and the constants, I'm not a very constants. So 5 by 5 no, so gikan diri hantod diri. So that is 5 by 5. Ito na lang i-highlight so that we can trace it. So, ano siya, times the unknown variables, which is equals to the constants, no? Okay. So, first equation, we have 6 C1 minus C3, 50. So, 6. And then, walay coefficient sa C2. Dayon, negative 3, negative 1. 0, 0. This is C1. This is 50. Okay, for equation 2, we have C2 is equals to C1. Or C1 minus C2 is equals to 0. No? So that should be 1. From the original, gikan diri, that should be 3C1 minus 3C2 is equals to 0. So, usab lang na to. Ito lang i-correct diri. So that should be 3C1 minus 3C2 is equals to 0. And this will be your equation 2. So that should be in this, that should be 3. 3, dayon negative 3, then puros na 0. So this will be C2, 0. For equation 3, we have negative 0, ay negative C2 di ay, negative 1, dayon 9C3, dayon 0, 0, C3, dayon C3, dayon 160. For equation 4, that is negative 1, 0, dayon negative 1, dayon negative 8, dayon 11, dayon negative 2, dayon C4 ni, dayon 0. Lastly, this is negative 3. This is negative C in negative 2 di ay negative 1. Sorry, dayon 0, dayon 0, dayon 4. Then this is C5 here and 0. Okay, so we completed the values. So next is finding the matrix inverse. Before that, let's just declare that This is, say, matrix B, 8 matrix A, then matrix C. Therefore, your matrix B is equals to inverse of matrix A1 times the matrix C to find the values of the concentration. So, kuha na to letter A, kuha na to sa matrix inverse for A. So, equals to matrix inverse Okay, so since we are taking the inverse of a 5 by 5, so we highlight 5 by 5. So sakto na ni. Then again, function for matrix inverse is M inverse. Highlight the array, then control shift enter. Now you can find now the values of your C1, C2, C3, C4, C5, which is equivalent to, let's just highlight this. So atong C1, C2, C3, C4 is equivalent to multiplying the M multi the inverse matrix A times comma the second array, which is the constants, which is here, and control shift enter. So yeah, so this is the value for your C1, C2, C3. Okay, so how about in solving Gauss-Seidel method? So let's just copy the equations. For a while. So we will uh, try to transform these equations as instruction for Gauss-Seidel. So mura siya simple fixed point, no? Sorry. Okay. So for reactor 1, we have C1 is equals to 50 plus C3 all over 6. That is new equation. So let's just say equation 6. So C2 is equals to C1. So this is equation 7. For C3, so that is C3 is equals to 160 plus C2 all over 9, equation 8. C4, that is C4 is equals to C2 plus 8C3 plus 2C5 all over 11. That is equation 9. For C5, that is 3C1 plus 3C2 all over 4. So that is equation 10. Okay, hang up ang computer. So okay, this is Gauss-Seidel method, no? Gauss-Seidel method. So what we really need for Gauss-Seidel method is iteration equation, so that we can create a table. So for iteration equation, we have here for C1, that is I plus 1, which is equivalent to 50 plus C3 I all over 6. For C2, I plus 1, that is equivalent to C1 I plus 1. C3 equivalent to kani, so which is 160 plus C2, this is I plus 1 and this is I plus 1 all over 9. C4, updated values for C4, that is I plus 1 na C2 I plus 1 plus 8 C3 I plus 1 plus 2 C5 I. C5, pila to ang C5, which is 3 C1 plus 3 C2. Sakto ba? Ay, sayop. So, C2 ra ni, C2. That is 3 C1. So naman yung 3. So that should be 3 C1 plus C2 all over 4. So this is I plus 1. This is I plus 1. I plus 1. Notice in your second equation, that is C2 plus equals C1, no? So we can combine this pero pwede sa D. So mo ni mong iteration equation ha, kani over 11 pa ni siya. So let's have a table here. So iteration starting from C1, C2, C3, C4, C5, error 1 till 5. So yeah, starting with 0, initial guess. I don't mind if that's 0. No relative error yet. Color code this. So yeah. So at first iteration, plug in is formulas above. So for C1, that is 50 equals 50 plus C3 divided by 6. C2, which is equivalent to C1, I plus 1. C3 equivalent to parenthesis 160 plus C2 updated value divided by 9. 4. So that is parenthesis C2 parenthesis C2 plus parenthesis 8 times C3 updated value close parenthesis plus parenthesis 2 times C5. Yeah. Divided by close parenthesis divided by 11. Last one is C5, which is equals to 3 times C1 plus C2 divided by 4. Now, can iterate this automatically by dragging. So here I think we can create now a relative error. So that is equal of absolute value of the difference of the old and minus the new divided by the new. So just drag this, just equal, just make it this as formula, while this makes you in think three decimal places. No, 2 decimal places. So let's just drag it here, just change this. Okay, so drag it, and actually in the third iteration or in the second iteration, kanisha ordery, we can say that we can have the answer already. So that is the same, no? 11.51, 11.51, 1906, 17 og 11.51. So same ragid siya og kuano og answers. So the idea here is to do not complicate the matrix, no? Since we introduce matrix in Excel, so na easy ra, no? So what if we are trying to solve in a paper, solving mano-mano for the matrix inverse, then maglisod ka duway ka mahuman ani, then diri na part, although you get the same value, no, which is this. So let's just delete this. Okay, redundant siya. So what is the point here? So in engineering applications, you have to create the equations before applying the methods in numerical method. So nag-create pa tawag equation, which is a much challenging one because you need to understand the theory, the principle, because if you don't know law conservation of mass, maybe you cannot create this equation. And if you know that mass flow is equals to QC, you cannot create this also, the equation. So you need also to have scientific background of the problem that you are reading so that you can create these governing equations, and afterwards translate these governing equations into iteration equation, then apply Gauss-Seidel. Okay, so that is all. So thank you.